All right. So you guys both came down to the pier. Thank you for coming.
Thank you for being.
Yeah.
Show you. So on Saturday, oh, I'm not sharing. Okay, on Saturday, oh no, this was my son. This was my fix for Saturday. So we had our Altair, Alcade, Saturn, all kind of bearing the same, and then Moon and Antares kind of gave us a better cross. But it is, what do we say, a 10-mile triangle, give or take. So, and then my Jupiter, I don't know what happened to Jupiter. My Jupiter's, and that was the big bright one. So I don't know what happened.
Yeah.
We'll see if today's better.
Same as my noon key.
Yeah,
Just went off the chart.
just went somewhere. So all these papers. So you guys both used my little cheat sheet of writing it. So did you guys have any questions of how I created this? We went over that in week 4 or week 6. That we used 249. We're at latitude. There it is. We're at latitude 34, 257. I underlined it there. So I just did all 7 of these. So I plotted all of those. There are, you know, the diamonds on the ones that are going to give you the best fix. But as we experienced, the more you get, the more wiggle room you have. Because as we're going to see tonight, at least 1, maybe 2 or 3, we're going to have to throw out at one point. So yeah. So with this, I already put it into a site reduction form, just the information that the object, Saturn, time, and the HS, the sextant altitude with my index error.
Okay.
So that's all I've done. I did it for the planets, for the moon, and then for the stars. So we are going to reduce it, and then I have a blank universal plotting sheet. Okay. So what I also like to do is, I think I'll come up with one and put it on the Google Classroom to have a combined site reduction form that you could use for stars, planets, moons, pretty much everything that you're going to see in the evening. That way you can put it in chronological order, because as you see when we do this, it helps the little shortcuts to do it chronologically. So for the sun, I did a full sun, and then I did another sun, and then I did another sun. For this one, because they're all, you know, within a half hour of each other, I'm gonna well, I'm gonna do the planets, and then I'm gonna do the moon, and then I'm gonna do the stars. But I did put it chronologically. So actually we started with the moon. So we're gonna start with the moon chronologically. And as a caveat here, I shot Altair, Saturn, Jupiter, and then the rest of them I copied from other people's. I don't know, Tim or John or Ted's. I just used their information. So, so I am using, for mine, a 0 index error, but for everybody else's, I'm just kind of rounding to a 5.2 on the arc. That might be off, but we're gonna go with it. So that's why those index errors are gonna be different. I'm just throwing that out there. Okay. So now I'm not gonna use this one anymore because I did transfer the information, and it was just the time and the HS is what I got for each observation. And then I had the index error and the height of I. Okay. So let's get started. We're gonna start with the moon, go all the way. I'm gonna zoom in here a little bit. Okay, so I have August 23rd at 1937. My zone description is going to be a +7. So I have, I'm already needing my calculator. -26 -2. 24, so 02. So my GMT is going to be 02:37:10 on the 24th, on the next day. Use this guy. So I added my 7 and I got 02. So we go to the Nautical Almanac. We go to the 24th at 02, and we're looking at the moon. So we have GHA, little v, declination, little d, and HP. So I'm going to copy down all of these numbers. I'll show you, we put GHA, so that's GHA on the top of the hour, was 144. 32.2. My little v was 9.5. My declination was 11 degrees 06.0 south. And my little d is 13.2. And then my HP was 59.7. So I just copied that information in. Okay, so now I'm gonna do my minutes and seconds. That's our increments. So we were at 37:10. So for 37 minutes, 10 seconds, we're going to be on the moon. So that's that third column over. So the moon gives us 8 degrees, 52.1 seconds. And then, under my 37 minutes, I have a V and D correction. So my first V was 9.5. So 9.5 on V is going to give me 5.9. So I have 5.9. And my B was 13.2. So that's going to give me 8.3. And I forgot to say if we were increasing or decreasing our declination. So we were the 24th, and we are increasing. Okay. So now I'm going to use my handy calculator. Let me move this real quick. Okay. So I have 32.2 plus 52.1 plus 5.9 gives us 90 minus 60 gives us 30.2. Carry the 1. 144 plus 1 plus 8 gives us 153. So that is our GHA. And we want our LHA to be a whole degree. So we're going to subtract our western longitude at 30.2. My DR longitude is 117.55. So I'm going to use 117 as my assumed longitude. So then I have these cancel out. I have 153 minus 117 gives me 36 degrees as my LHA. Then I have declination was 6 plus 8.3. 14.3, 11 degrees south. And our latitude, we're going to round up here to 34 degrees north. So we're going to have a contrary. So these are the three things that I go to Pub 229 with. My LHA, whole degree, latitude, whole degree, and then declination has a minutes on it. I don't know if you noticed, Robert, on my, I sent him a picture of my site reduction. Which one was it? It was Saturn. Yes, Saturn. I put the wrong assumed longitude. My 117.58 would have been closer to 117.56 than 118.
Right, right.
So I was, off, which then made my intercept larger.
Oh, okay, right.
So my, so if I'm looking at this, my assumed position was right there instead of right here. So that would have been closer to my DR, but I used this one, which just gave me an angle that was different and a further intercept.
Right.
So whatever, assumed position that you use, well, my point is that it doesn't matter if it's wrong or not wrong. It will correct for itself.
Right.
So I did it on that one, and I didn't even notice it until I plotted it, and I was like, well, that's way off, but yeah.
Gotcha. Yep.
Okay.
So it's good that it corrects itself.
Yes, it corrects itself.
Yeah.
So, yeah. If you are testing for the U.S. Coast Guard exam, they are assuming there's some of their questions don't go all the way to a full plot.
Ah, okay.
Most of the questions don't go all the way to a full plot. So they're saying, what is the assumed position for this stuff? So they're thinking, okay, you did the assumed position in this way, but
Right, okay.
in the real world, it's okay.
Yeah.
Okay, so we got our information to go in Pub 229, but before we do that, we're going to still use our nautical almanac to go from HS to HO. So, we have a dip. Does anyone remember our dip correction from last time?
-5.
-5. So height about between 26 and 27. So we're using -5 as our dip. So we can calculate our HA. 10 minus 5.2 minus 5 gives me 27 degrees, 59.8. And then I have my corrections, correction, HP, and 30. So those corrections, so on our standard correction table, we have the sun, the stars, the planets, and dip. We don't have the moon. So to get our moon correction, we go past our minutes and seconds table to XXXIV, whatever page number that is. 34, Roman numeral. So it's the altitude corrections for 0 to 35 on the moon. So we observed our apparent altitude. So our HA is 2759. So basically 28 degrees. You guys see that?
Yes.
So I'm gonna go to my 28. So at the top of this table, we have our apparent altitude in degrees, and then the minutes are down here. So we have 27.59 something. So this would be 2750 would be this correction. And then 28.0 would be this correction. So we're going to use that 28.0 because that's what we're closest to. So we're going to use 59.7. Happens to be our HP. So we're always going to add that 59.7. And then we're going to stay in the same column here. Staying in the same column, we're going to go down to our HP. So our HP was 59.7. So this is our HP right here. So we're going to go across to our column, and we have the upper or the lower limb and the upper limb. So we wanted to know which one we did, and the moon was kind of tilted, right? So we got the lower limb. So if the moon is tilted the other way and you can't see the lower limb, you can only see the upper limb, that's fine. Just put the upper limb right on the horizon. And you go to the upper column. Okay, so we got the lower limb. So that was 7.3 is our correction. And then if we did the upper limb, we would minus 30 minutes here. but we did the lower limb, so we don't do anything. So I can go back to my calculator. I have 59.8 plus 59.7 plus 7.3 gives me minus 120, gives me 0.6.8, carry the 2, and I have 29 minutes, 0.6.8. All right, how you guys doing? All right. Okay, so next, we do our 229. So in this portion is our 229, and we go from HC to HC, and then we do Z to ZN. So we're getting our calculated altitude and then our calculated bearing. So, and the highlighted, the 3 things are the 3 things that I'm using to find that information. So I have an LHA of 36. So here's my LHA of 36. I have a latitude of 34 on both sides, LHA 36, latitude 34. But am I contrary or the same? So I had a south declination, but I'm in the northern hemisphere. So I'm going to be contrary. So I'm going to be on the contrary side. And then, wiggle that out there, I had a declination of 11, between 11 and 12, right? So we're going to go to 11, and we're on 34. So I'm just going to draw a line here. So this right here are the 2 numbers we're looking at, in between 11 and 12. So I'll write our numbers in so we can see it. Our HC was 33 degrees, 29.0. Our little d was minus 48.9. And our z was 136.2 and 136.9. So right off the bat here, I think we're pretty far off. We're going to correct this a little bit, but our HC and our HO, 4 degrees off. I don't know if that's going to work out to a good intercept, but we're going to do it anyways. But if I was like really pressed for time, I might just move on to the next one. But I want to do the whole thing. Okay. So we are multiplying that difference, that little d, by the leftover of our declination. So we had 11 degrees and then 14.3 sixtieths to get us to the next, to where we are. So 14.3 divided by 60 gives me that number times 48.9. I'm going to be subtracting 11.7. So I have 29 minus 11.7 gives me 17.3. 33 degrees. Then I'm just gonna move my HO down here, 2906.8. So to get the difference here, a bigger one is on top, so I'll do 17.3 minus 6.8 gives me, put it over here, 10.5. 33 minus 29 gives me 4 degrees. So 4 times 60 plus 10.5 gives me 250 miles. Oh, so now we do our ho-mo-to. Our HO is less, so we're going to be away. So we're 250 miles away. Not a great intercept, but that's all right. Just had you do it anyways. Okay, so for our ZN, we had a Z of 136 and then 136.2 to 0.9. So our difference there was adding 0.7. So I'm going to multiply that by our 14.360th times 0.7. And we'll do plus 0.2. So our ZN is, or Z is 136.4. And then we have to convert our Z to ZN. So we use the Northern Hemisphere rules. Is LHA greater or less than 360? Our LHA was less than, so we're going to do 360 minus Z. So our Z, 360 minus 136.4 gives us a ZN of 223.6 degrees. So that is our moon. So I'm probably not going to actually plot that one, but we'll get to that at the end. We're going to reduce all of them, and then we'll plot. Any questions on the moon? We had a little bit, you know, it's a little bit different on the HS to HO. And then we had that little V correction. So that V, this is going to be the same for the planets and the moon. And then this part is unique to the moon.
And Tim may have missed our discussion about V always being plus.
Yeah, that is always a plus, so you don't need that subtraction. We always add our minutes and seconds, and we're going to add that V.
Great, thank you.
Yep. Okay. So, welcome, Janice. I just saw you popped in. Now we are going to do our Jupiter and Saturn. This is today, so I'm going to put that right there. Okay. So I have the time of each observation, and then I put in the Ross sextant altitude for each observation, and then I have a 0 index error. So I will start at the top and we'll work our way down. 1930 zone time with the 7 is going to give us our chronometer time of 02:39:09, and that's going to be on the 24th. Same for this one, 02:54:05. That is going to be on the 24th. So now we're going to dive in to the almanac. And we are on the right side now. Need a bigger desk. Okay. So we had the 24th at 02, and we did Jupiter and Saturn. So I'm going to get our GHA of Jupiter and our declination. Let's do that one first. So Jupiter 02 was 7313. .0, and my V down at the bottom for Jupiter is 2.6. My declination for Jupiter is 2237.1. And that was south. And so my little d is 0. And when I look at this, the 02 was 37.1, and my 03 was 37.2. So because I am at 3909, I'm going to do that 37.2 as my, because I'm closer to that one. It's only one tenth, but that's why I'm going to do that. So I'm going to do 22 degrees, 37.2 south. Okay. Before I go to minutes and seconds, I'm going to write my Saturn one. For Saturn, I had a GHA of 6423.3. And then I had a declination of 2109.1. And my next declination is the same, and that is south. Write that in. 21 degrees, 09.1 south. Oh, I didn't write down my little V was 2.6. Okay. And that's all we're going to get from that page for our planets. Now we're going to go to our increments, our minutes and seconds. So our first one was at 39. So here's our 3909. 3909, and we're on sun and planets. So I have a minutes and seconds of 9 degrees, 47.3, and then my little V was 2.6. So I have a correction of 1.7. And I already did my little D's, so I don't have to do those. Okay, then I'm going to do my 54. Turn page a couple times. Here's our 5405. We're again in planets. So we have 13 degrees, 31.3, and our 2.6 is going to give us 2.4. Okay. So now I'm going to add these numbers up to get our GHA. So I have 13 plus 47.3 plus 1.7 gives me 62. So I have 0, 2.0, carry the 1, and that's left with 83 degrees. I'm going to do the Saturn. I have 23.3 plus 31.3 plus 2.4 gives me 57.0 and 64 plus 13 gives me 77 degrees. Okay, so I have my GHA of each planet, and now my next step is to get my assumed longitude. I want my LHA to be a whole degree, so I'm going to be subtracting west, so my assumed longitude is going to end in whatever I have here. So I have 0, 2. So my assumed longitude is going to be 0, 2 minutes. And then I'm going to have 117 or 118. My 118 is going to be closest to my DR, so I'll use that. On this one, 57 is very close to 55. So I'm going to use 117 degrees 57.0 for that assumed position. Can I get the calculator work? Okay. So we have to subtract these. Both the 83 and the 77 are small, so we have to add 360. So we do 83 plus 360 minus 118 gives us 325. And then we have 77 plus 360 minus 117 gives us 320. Our assumed latitude, we're going to round up to 34 degrees north. 34 degrees north. And now we have our latitude, our declination, and our LHA. And those are the things that bring us to Pub 229.
Okay.
Making sense so far? Are you guys doing it on your own too? Like following along, or are you just watching my math?
I'm watching your math right now.
Okay. Cool. All right. Well, our next step is to go to, oh no, we don't have Pub 229 yet. We have to do HS to HO. So our HS we have, my index error is going to be 0. Do you remember what the dip was?
Minus 5.
-5, yeah.
So we don't have to look that up every time because it's going to be the same. So we have an HA of 24. I can't do math in my head. Okay, so I have my HA. So now when I go to my A2 table, I'm under stars and planets. So I'm here on my stars and planets. And I have an assumed, apparent altitude of 24 degrees 38. So I'm going to find 24. So in between 24 and 25, I have a correction of minus 2.1. And while I'm already here, I have between 23 and 24, minus 2.2. We don't have an A4, and we didn't do Mars or Venus, so we don't have those. My head. So now we have 36.7, 24 degrees, and we have 15.6, 23 degrees. Now we have our HO. Now we're going to go to our HC, or to calculate our HC, we're going to go to Pub 229. All right, here's 229. We're going to find an LHA of 320 and 325. Okay. Here's our 325. We are on contrary. We have a north and south. So we are on the contrary side. Okay, so we have 34 degrees. And our declination for Jupiter was 22. So we're going to go down to 22 on 34. I'm going to write it big so we can see it here. 24 degrees, 50.8. My little d is minus 51.2. My z is 144.1 and 144.7. Okay, so at this point, I'm going to calculate all the way down to Zn. So in order to get between the 22 and 23, we have to multiply by our remainder, because our declination was 22, 37.2. So we are 51.2, 37.2 divided by 60. Make a note of that, 0.62. And then I'm going to times that by 51.2, gives me minus 31.7. So I have 50.8 minus 31.7, gives me a calculated altitude of 19.1 minutes, 24 degrees. Then I'm going to move my HO down to the bottom here so I can compare the two. 24 degrees, 36.7. They are pretty close, so that's already looking good. 36.7 minus 19.1 gives me 17.6 nautical miles. Now, am I away or towards?
Towards.
Towards. HO is bigger, so we are towards. All right, so then our Z to ZN, we have 144.1 and 144.7, so we added 0.6, and then I'm going to multiply that by our 37.2 divided by 60, which was 0.62. So 0.62 times 6 gives us plus 0.4. So we'll call that 144.5 degrees. And then we follow our rule. Is LHA greater or less than 180? Our LHA was greater, it was 325. So our ZN is equal to Z. So I have my ZN of 144.5. So that was Jupiter. Now we're going to calculate our altitude and our azimuth for Saturn. So our LHA was 320. So we have LHA 320, 34 degrees north, and then our declination was 2109. So we're going to find 21. You guys can't read that. So we have 23 degrees, 06.6. Our little d is minus 49. Our z was 139.3 and 139.9. Okay, so our remainder here is 9.1 for our declination. So we have, oh, you guys can't see that. 9.1 divided by 60 times 49 gives me minus 7.4. So 6.6 minus 7.4 plus 60 gives us 58.6, and that's going to be 22 degrees, 58.6. We'll move down our HO, and we get 23, 15.6. Still pretty close here. So we have 15.6 plus 60 minus 58.6 gives us 17 nautical miles. And is it away or towards?
Away.
Oh. HO is bigger. It's the 23.
Oh, 23, I'm sorry, yeah.
Yeah, even though that 15 is
Yeah.
smaller, that'll get you every time. We are towards. Okay, so then our Z, next Z, we are adding by 0.6. And we have just a little bit, 9.1 divided by 60 times 0.6, 0.1. So our Z is 139.3. And was our LHA greater or less than 180? It is greater than, so it is the same. So 139.3 degrees. And we have no advancing or retarding. So I know I did that very quickly, but I want to get to the stars because we have 7 stars. Any questions on the planets? All right.
Nope.
They were the biggest and brightest out there, right? We saw those ones first. Okay, so those are the planets. And now 6 stars. 1, 2, 3, 4. I have 6 stars. That's still a lot. Yeah, we're gonna dive into this. Any questions before we dive into the stars?
No.
All right. Okay, so get comfortable here. We have our zone description +7. So to get our GMT time, we are again at 02, 57, 13, and that's on the 24th. On the rest of these, because I have them in chronological, it's going to be on the 03 hour. 01, 56, 03, 07, 26, 03, 11, 50, 03, 14, 39, 03, 15, 27. Okay. So that's our GMT. And our first step is to get the GHA of Aries on the top of the hour. So we're going to be on the 24th. We have the 24th at 02. Our GHA of Aries is, where is it up here? 2 degrees, 48.8. And then for the next, we're going to go down an hour to the 3 o'clock hour. So we're going to go down to the 3 o'clock hour, and we have 17 degrees, 51.2. And that is the same because these are all on the 3 o'clock hour. So we have 17 degrees, 51.2, 17 degrees, 51.2, 17 degrees, 51.2, 17 degrees, 51.2. All right. With me so far?
Yep.
On this page, the other 2 things we need from this page is the star's SHA and declination. So that star is so tiny and so far away that its declination is not going to change by the hour. So it might change a couple months later, but it's so far away that it's not going to change hourly. So we don't have that little correction. So we're going to write our SHA and our declination. So this is going to be our hunting. Our first one is Altair, and it is in alphabetical order, so that helps. So we have our SHA of 62 degrees, 03.1, and a declination of 8 degrees, 55.5. And we have Nuki, (75 degrees, 51.9, and 26 degrees, 16.2 south. And Antares, 2 degrees, 21, and south, 26 degrees, 8, 6. Arcturus, 145 degrees, 51.3. (19 degrees, 04.8. Ica, last one, Alcade. Alcade. All right. So we're just filling in at this point. We filled in our declination and our SHA. So as I was writing that, I noticed what I was doing and I wanted to explain it. On my declination, I always put my indicator, if it's north or south, on the end, because for latitude, that's where I put it. I put my 34 degrees north. So it's just easier for me to see here if it's contrary or declination, because that's a very easy common mistake to make. So I just have a habit of writing my declination indicator at the end, because when it's at the beginning, I don't know, I get confused if it's, you know, part of the two. I don't know. I guess I'm just saying. Okay. I guess we're doing our latitude. Our latitude is 34 degrees north all the way across. I wrote 32 for some reason. Okay. So we have to finish out here to get our LHA. So our minutes and seconds is next. And I'm actually going to start with this minutes and seconds and work my way up, because it's going to get bigger and bigger. So I'm going to start at the 156. So, and we are in Aries. So this is our second column. We have the GHA of Aries. And so our minutes and seconds correction is going to be that middle column there. So my Nuki is 156. So I don't think I'm going to be able to get this all on the same page here, but we have a minutes and seconds. Here it is. Minutes and seconds of 156. .1 seconds. Then we go to our next one of time is 7:26. So we go to 7 down to 26. We go to that middle one, and we have 1 degree, 51.8. Our next one is 11:50. The middle one, we have 2 degrees, 58.0. Our next one is 14:39. Next page, 14:39, 3 degrees, 40.4. And then we have 15:27, same page. 15:27 is 3 degrees, 52.4. And then our last one, which is also our first one, is 57. So that's towards the end. 57:13. 14 degrees, 20.6. Okay, so I know I did that incredibly fast, right? Those minutes and seconds numbers. But that's just showing you, like, you know, you kind of learn these little shortcuts as you do it more often. That if you have series of them, you don't have to like close the book and then open it and then close the book 6 different times because we did 6 stars. We're kind of like not combining this, but I don't know, saving our arm muscles so we're not flipping back and forth through the book and confusing ourselves. So I just kind of look at it by one task at a time. Okay, now we're doing minutes and seconds, and I do all 7 of them in order. And that's why I like to put it in chronological as well. Okay, so now we calculate. So our minutes and seconds and our SHA, we're going to be adding to get our GHA. And then we create our assumed longitude. So we're going to add these 3 numbers to get a GHA. I'm just going to add those all the way across the board here. So I have 48.8 plus 20.6 plus 3.1 minus 60 gives me 12.5. Carry the 1. I have 3 plus 14 plus 52 gives me 9 degrees, 12 minutes. Right, next one, 51.2. Carry 2, and I have 19 plus 75 gives me 94 degrees. 51.2 plus 51.8 plus 20.1 minus 120 gives me 0.3.1. Carry the 2. 19 plus 1 plus 112 gives me 132. 51.2 plus 58 plus 3. 5, 2, 19 plus 2 plus 5 6. 51.2 plus 40.4 plus 26.2 equals 8. 1, 18 plus 3, 8, 9, and 22 plus 52, 4, 35.2 minus 120, 38.8, carry 2, 19 plus 3 plus 2, 174. Okay. Kind of blurry all of a sudden. So that was a lot of calculator work. Did anybody notice a pattern on our GHA? Maybe we'll notice it. Wait, we'll wait to the LHA and then we'll notice it. Pause, we'll wait to the LHA. Okay. So for LHA, we're doing our assumed, we want the whole number. So we want we're subtracting because we're in the West. So our number is going to equal this number. So it's going to end in 12.5, and that is going to be closest to our 118. This one is ending in 12.2, so that's going to be closest to 118 as well. 03.1, 118. 40.5, that's going to be closer to our 117. 57.8, that's going to be closer to 117. And 38.8 is going to be closer to our 117. Again, if we do 118 instead of 117, not the end of the world. Okay, so we're going to subtract and a lot of these are less than, so we have to add 360 to that. So 79 plus 360 minus 118 gives us 321. Our 94 plus 360 minus 118 gives us 336. 132 minus 118 gives us 14. 117 minus, 166 minus 117 gives us 49. 179 minus 117 gives us 62. 174 minus 117 gives us 57. Okay. Did anybody catch the pattern yet? Okay, so this is west, this is east. the sun passes our position at noon, and then it sets over here, right? That's where the sun set at when we shot. So the sun was over here or slightly below the horizon, moving this way when we shot these stars. Our LHAs started in the 320s. So they at 320. So that started, we do 320 degrees. Somewhere around here was our first one. And then they got bigger. And then we was past our zenith, and then we started at 14, and then 49, and then those two I didn't take out of order, or I took out of order. But then we had 57 and 62. So when you're looking at this, and we shot in order, if we shot, exactly Altair, Nookie, Antares, Spica, Arcturus, Alkaid, that those numbers are increasing. I don't know if that makes any sense, but I just wanted to show you the pattern. I guess I'm a dork. Like, it's cool because it's a pattern.
No, that makes sense.
Okay.
Yeah, that's good. That helps.
Okay.
Yeah, I didn't catch the discontinuity in the middle though, from 336 to 14. I was curious about that.
Yeah, it passed our meridian.
Right, yeah, makes sense.
Yep. Because the sun set, and then we took our, in the west, at our 090. But, okay.
And nothing's greater than 90 or less than 270.
Yep.
Great. Interesting.
Let's get back at it. So I am using 5.2 as my index error. Again, that was just kind of average because I came up with these from a lot of different students. My dip, remember it was -5. Write that in. So we have, so now I'm just going to calculate our HA for all of these. So we have 42 minus 5.2 minus 5. That's a strange number. Let's try that again. 42 minus 5.2 minus 5. That's better. 31.8, 46 degrees. Okay. We have 15 minus 5.2 minus 5 gives us 26 degrees, 04.8, 48.4 minus 5.2 minus 5. Should just make this minus 10.2. 38.2. 28 degrees. 55.6 minus 5.2 minus 5. 45.4. 14.5 minus 5.2 minus 5 gives us and 30 minus 5.2 minus 5 gives Okay, so now I have my apparent altitude, my HA. So to get our A2 correction, we're in the stars category. So this is our apparent altitude, and these are my corrections. So there isn't any order to this one because they were all at different altitudes, but I'm just gonna work my way. So we have 46, so that's lower here. So we have 45 and 48. So our 46 correction was minus 0.9. Our 26 degrees, we have 2512 and 2620. So our correction is minus 2.0. 28 degrees is going to be minus 1.8. 45 degrees, or 44 is going to be minus 1.0. 16 is going to be minus 3.3. And we have another 46. 4619 is minus 0.9. So I just kind of worked my way up that table and filled in my calculations. So now I can do 31.8 minus 0.9 gives me 46 degrees 30. Okay. 26 degrees 02.8. 58 degrees 38. 44.4, lots of fours. 4.3 minus 3.3, 1.1, and 19.8 gives us 18.9. Okay. So we have our HOs. We are done with an almanac, and we are also done with doing all 6 at the same time. Now, in 229, we finish each one off and then move to the next one. Finish it off and move to the next one. Because these are all going to be on different pages. So we're not saving time by flipping back and forth. So that's the method to my madness. Other people may do it differently. Okay. And I feel like it's also the moment of truth when we figure out our first HC, and it's close or not close.
Yeah.
Okay, so let's get started. Oh, I didn't highlight. The 3 things we need are our LHA, our declination, and our latitude, all right there. Our first one, we have 321. All right, so we have 321 and then N and N, so they're going to be the same. So we are on this side, declination same. I lost my ruler. There it is. Okay. So we have 321, 14, and then our declination is going to be 855. So here's our 8. I'll write in these numbers so we can see them. We are 45 degrees, 42.7, and we are plus 39.6. We have a Z of 1168 and 115.7. Okay. So we are ballpark pretty close, so I like what I'm looking at so far. We need to multiply our D by the remainder. So our 55.5, that's going to be pretty close to 60.925. And I'm just going to write that in down here. 0.925, just so I don't have to do it again. These are the little time saver shortcut things that you'll get along the way. 0.925 times 39.6 gives me 36.6, so plus 36.6, 42.7 plus, dang it, 42.7 plus 36.6 minus 60 gives us 19.3, carrying the 1, 46 degrees, 19.3. RHO was 46 degrees, 30.9. So I subtract 30.9, I get 11.6. And are we away or towards? Are we homo-to? Our HO is bigger. Is that right? Yes. Our HO is bigger, so we are towards. Okay, so now we have 116.8 and 11, so 6.8 minus 5.7, math there. We had subtract 1.1, so I'm going to multiply that by my 0.925, and I get minus 1.0. So I have a Z of 115.8. Now I need to do Z to Zn. Is my LHA bigger or less than 360? It is bigger, so my Z equals Zn. So I have 115.8 as my Zn. How did that go? I know I'm doing it quickly, but making sense so far? Okay.
Yep, good.
So now we are at 336. Chug it along. 336, and we are contrary. We have a north and south. So we are contrary. And our declination was 2616.2. So 26. And we have an HC of 25 degrees, 49.3 minus 55.6. Z is 156.0 and 156.5. Okay. My remainder on my declination was 16.2. So I have 16.2 60ths. 0.27, write that in there, times 55.6 gives me minus 15. So I have 49.3 minus 15 gives me 25 degrees, 34.3. Then I move down my HO, which is 2602.8. And I'm going to do 62.8 minus 34.3. And I get 28.5. Away or towards? Towards. Excellent. My difference between Z and next Z is plus 0.5. So I have 0.27 times 0.5 gives me 0.1. So my Z is 156.1. And my LHA is greater than 180. So we are staying the same, 156.1. All right, 2 down, 4 to go. Next LHA is 14. And we are contrary, a north and a south. So I have LHA of 14, 34, and then 26. Declination on these guys. 26, 28. So 26, 34. Okay, so we have 28 degrees, 32.8 minus a 58.5, and then we have a 165.7 and 165.9. Okay, back to the calculator. Our remainder here is 28.6, almost half. 28.6 60ths gives us 0.477. I'm going to write that down here. 477 multiplied by our 58.5 gives us a minus 27.9. So 32.8 minus 27.9 gives us 28 degrees, 04.9. we bring our HO down, and we get 28 degrees, 36.4. So we have 36.4 minus 4.9 gives us an intercept of 31.5. And our HO again is bigger, so we are towards. There's a lot on this. Okay. Our difference between these are going to be plus 0.2. So 0.2 times 0.477 gives me 0.1. So I'm going to be at 165.8. And now our LHA is less than 180. So we are going to do 360 minus Z. (360 minus 165.8 gives us 194.2. That's our ZN. Now remind me at the end of this to, because I feel like we're clicking on those LHA and what that really means. Remind me to show you the slide of the celestial triangle again. And it will be like, oh, that's why we are adding, you know, ZN is, if it's less than or greater than 180, we either leave it the same or subtract 360 minus. So it's not just this like made up thing. It's because of the celestial triangle. Are you outside of the triangle or inside of the triangle, basically? But just let me show that one too. Okay. Halfway there. 3 down. LHA 49. And we are same. So we are on same declination. LHA is 49, 34, and 19. 19. Okay, so we have our numbers. This was all the 4s. 44 degrees, 08.0 plus 29.0. Our Z is 96.2 and 94.9. Okay, so now it's time for our calculating. Our remainder on the declination is 4.8, very small number here. 4.8 times, divide by 60 gives us 0.08, 0.08. And we multiply that by 29.0, gives us a plus 2.3. So we get 44 degrees, 10.3. Our HO was 44 degrees, 44.4. So we get our difference to calculate our intercept, 44.4 minus 10.3 gives us 34.1, and our HO is bigger again, so we are towards. Okay, our differences between these guys, we have 6.2 minus 4.9. We are subtracting 1.3 times 0.08. Gives us subtraction of 0.1. So we have a 96.1 Now, again, our LHA is less than 360. So we, less than 180. So we do 360 minus 96.1 gives us 263.9 is our ZN. Chugging along here, guys. Next, LHA 62. There's 62, and we are contrary. We're contrary, 62, 49, or 34. Our declination is 11:15. So 11 and 34. Plug in our numbers here. -15 59.0 minus 39. C is 115.6 and 116.4. Okay, so to the calculator. Our remainder here is 15.9, so give or take 0.25. 15.9 divided by 60, 0.265, multiplied by the 39, and we get our correction of minus 10.3. So we have 59 minus 10.3 gives us 48.7. Then we're going to move our HO down. We have 16 degrees 01.0. So we have 61 minus 48.7 gives us 12.3. And again, that is towards. I don't know if we're going to get any erased this time. I don't know. Okay, 116.4 minus 115.6. Difference is 0.8 times 0.265 gives us 0.2. We are adding that. So we have 115.8 degrees. And we are 360 minus. $244.2. Okay. I feel like I'm going fast right here. Do you guys get what I'm doing with these numbers? How I do the difference, 0.8, and this was the increment number. Okay.
Yep.
All right, last one, and then we get a plot. Okay. 57. And we are same. And our declination was 49, a high one. Declination 49. 34. And 57, okay. I'll plug in our numbers here. We have 45, 54.6, plus 1.8. Our Z was 52.3 and 50.8. Okay, so to the calculator. Our declination increment is 13. So we have 13/60ths, 0.217. Multiply that by our 1.8, gives us 0.4. So we have 55 even, 45 degrees. We move our HO down, 46, 18.9. So we have 18.9 plus 60 minus 55 gives us 23.9, and that is 2 wards. All right, then we have 52.3 minus 50.8 gives us a minus 1.5 times 0.217, and we have a minus 0.3. So we get 0.52 degrees, 360 minus 52, 308. Woo! All right. So that's a lot of numbers right there, isn't it? Did a lot of work on that. Let alone the other two that we did. Let's add those in. Who said it's quick? That's a lot. Can't even get it on one little thing. All right, so now we plot. That's the fun part. See if any of this actually works out. It's been 2 hours. Thank you for bearing with me. Let's take a 5-minute break. Yeah, let's come back at 8:05 and we'll plot. So get a, I know I did all the math here, but get a plotting sheet out so you guys can do this one with me for plotting. All right, I'll be back in 5 minutes. Screen. I have already, for the convenience of time, set up my plotting sheet. Have you guys set up your plotting sheets? There we go. Now we can see it. Okay. Go over a little bit here. Uh-oh. There we go. Okay. So we got our plotting sheet. We got a pencil. We got dividers. So I am going to start with the stars, see what kind of fix we get. Does anyone remember which 3 they thought were going to be good?
I don't.
What did I say? We had it once upon a time. They said it was going to be Deneb, which we didn't even shoot, Antares, and Alcade. Okay, I said freeze picks were Arcturus, Antares, and Altair. But we'll see what we get. Okay. So what we need to plot is our assumed longitude, assumed latitude, so we have our assumed position, and then our intercept and our ZF. So our first one is, they're all going to be along 34, and then our longitude is 1812.5. So I'm going to use the scale down here. Focusing. So I'm going to put my dividers. So that is 0. And this is 2, 4, 6, 8, 10. So I'm going to put it on the 2. And then I'm going to put it on the 10. So that's 12. So I have 12.5. So I might make it a little bit bigger. 12, just a touch, 0.5. So I'm at 118, 12.5. Okay. So that, I think I messed it up already. Okay. So that's my assumed position. My azimuth is 115. So I'm going to find 115 and my ruler. A little tiny ruler here. 115.8. And I'm going to bring that to my assumed position. There, go off of. So now I have my azimuth line, and I need to plot my intercept 11.6 towards. So let's find 11.6. Okay. And now we'll plot our first star is Altair. I'm going to erase that guy. Just clean it up a bit. All right. Are you plotting yours, Tim?
I am.
Okay. How'd yours come out, Robert?
Pretty good, I think. Yeah. Pretty close to yours, a little off.
Okay. Are you guys using my numbers?
Yes.
Yes.
Okay. Okay. Okay, so that was our first one. Our next one, we have 1812.2. So I'm going to say that's at the exact same spot because my accuracy of 0.3 and longitude is not there. And then I have my intercept and my bearing. So my assumed position, I'm saying, is the exact same spot.
Mhm.
This time my azimuth is 156 and I'm 28.5 towards. So I'm looking for 156. Go 156. Same spot. And this time we are 28. And my miles is 28.5. 25, 26, 27, 28, 25. Pretty dang close. That looks like a good one. So for me, that one goes right through our position. I put the pink dot on there to show us our actual position. As I'm doing this, I'm just remembering when you get your intercept, remember to use the latitude scale for nautical miles. Easy mistake to use the longitude scale.
Right.
So remember that miles is going to be on that center line right there. Okay. We ready for the next one?
Yep.
All right. Assume longitude 118.03, and then we have a 31 and a 194. Okay, so trying to get 3 on this is going to be about 3. You call that 3. Okay, so there's my assumed position, and then my bearing is 194. I'm going to find 194. 194. Okay. Bring that over. Line. Okay. And I am 31.5. We're getting a pinwheel in a square. So, oops. Made it a thick line. That's all right. This is Antares.
Sorry, what was the intercept again?
The intercept was 31.5.
Okay.
Do you guys get a little bit of a pinwheel or a small triangle? Yeah.
Yeah. Yes.
Oh. Okay, let's plot some more. Our next one, Arcturus, is going to be from 117. So we got to take a mental note of that for our assumed longitude. And then it is 40.5. So we'll get 40 degrees of longitude, 40.5. And again, this one's from 117. So 117, 40.5. So our assumed position is over here. Our bearing is 263.9 at 34 miles. So 263, 264. Okay. Bring that down. $34.1. We are really getting a pinwheel here.
It's not in the right spot, but
I know, this is not what's supposed to happen. And this is,
no, I didn't. So when you draw your dotted line, how do you know where not to leave a gap so that you can measure the right?
I kind of ballpark, like if it's around 10, I'll usually draw a longer line, about 10, or if it's about 30, I'll kind of like eyeball it and draw, you know, a 2-inch line there and then dotted.
I see. Okay.
So
That makes sense.
just really eyeballing. All right. Next one, we got 57.8 for our longitude, 12 and 44. Okay, so 57.8. I'm right on that line for me.
Yeah, me too. Right on the line of position.
Yeah, that's my assumed position. We have a bearing of 244. And our distance was 12.3. And this was Micah. All right. So Micah was a little bit closer to our original position.
Yeah.
Cool, cool, cool. All right, last star. We have 38, 29, 308. So 30.
Sorry, what are those numbers?
We have a longitude of 38.8
38.8.
for 117, 38.8. And then we have an intercept of 23.9 towards, and a azimuth of 308. Well, this is going to be off.
Yeah.
Are we sure it's towards? Yeah, it is towards.
Yep.
That's not 20. We got a lot of lines on our plate.
Yeah. It's getting pretty crowded.
Yeah. Well, we got 3 more to do.
So this could intersect in a couple of different places.
Yes. So because we know our position, we can kind of tell which ones, you know, the Nuki and the Spica were very close. And Antares. So if we just had Nuki, Spica, and Antares, that would be a really good fix. That's a very small triangle, maybe like 5 miles. I'm looking at this triangle.
But yeah, you also have Antares, Altera, and
Yeah,
the last one, oh, Arcturus, make another triangle.
Yes, there's a lot of triangles on here.
Yeah.
I'm just using the knowledge of that I do know where I am. But yes.
Yeah, people in my.
So if you know your DR.
Yeah.
You could put that in there as a, hey, that one's way out in the woods.
Yeah, that's true.
Let's scratch it.
Kind of like people in my chemistry class that cheated, fudged on their numbers.
Oh no. Okay. Now for the moon. We'll do the moon and then the planets. So our moon, (11730). Oh, we have an away this. Oh, wow. We're not even going to plot this one. This one was 250 miles away.
Oh,
Right.
right.
Yeah, that one. We're not plotting it. All right. It's off the page. All right. Let's do our planets. So we have 1802, and then we have an intercept of 17 towards, and a ZN of 144. So our Jupiter and Saturn lines should be pretty close to each other because they were so close in the sky. But let's draw it out. 0, 2, 18. And 144. This is going to confuse our false pinwheel even more.
So is there such a thing as having too many points?
Yes,
Yeah.
absolutely. So this was Jupiter. All right, last one. just to add to the confusion. $117.57.
$57.
Right where our other one was.
Yeah.
And then 139.
Towards,
17 even. Woo, we did it. All right. Cleaning it up a bit.
All right, got another one that's close.
We could see on here how our Jupiter and Saturn were so close in the sky. And then Nuki was real close to him too.
Yes.
And those LPs are very close to each other. So yeah, we can tell we want that spread in the sky just like we want the spread on our coastal nav.
Yeah, yep. Interesting. Okay. Oh, that's it. We're done.
That's it. Yeah. All that fun stuff. And yeah, I mean, I would say there's just so many lines on here. I mean, if I was to guess without a DR, you know, there's a lot focused right here.
Right, yeah.
And what we could say, if we said we were there, we're about 17 miles off. That's not too bad.
Yeah.
So, yeah. Okay, let me show you that image that I was talking about.
Yeah, the celestial triangle.
Okay, so share screen. Okay, so this is our 4 possible triangles. So if we are in the northern hemisphere and our LHA is greater than 360, then our Z and ZN will be the same. So that Z is from the North Pole to the star. So it's the azimuth of the star. So from me, what is the bearing of the geographic position of the star from the North Pole, right? That's the bearing. So if your LHA is more than 360 or more than 180, those ZNs are going to be the same. If your LHA is less than, meaning that the star is to the west of you, right? Because LHA is always measured west. So if the star is to the west of us, our LHA is going to be less than 360. So our ZN from the North Pole is 360 minus Z, because it goes from the North Pole all the way, so we can measure it there for our ZN.
Oh, and it's always clockwise.
Yes, so
Got it. Yeah.
just like the compass, our azimuth is the bearing towards from us. Where is that star geographically?
Right.
You know, the geographic position of that star. So if you were to say the lighthouse is, you know, bearing 220, that's just like saying the star is bearing 220.
Right.
So that's
right.
that azimuth that we're calculating.
Got
So
it.
that LHA from us to the North Pole is that star to the east or to the west of us. That's
Okay.
why we do that little rule there. And then if you're in the South Pole, it's 180 plus or minus, because that North Pole star, you know, the north, that's our reference point. So if our Z is, or LHA is bigger than 180, meaning the star is to the east of us, right? So our LHA bigger than 180, stars to the east of us. LHA bigger than 180, stars to the east of us. Now let me show you on this guy. Quick reminder. LHA bigger than 180, the stars to the east of us. This is our LHA. So if it's bigger than 180, so if we're over here, all these stars are to the east of us, and all of these stars are to the west of us, or the sun has set in the western sky.
Yeah, okay.
Yeah.
If it's helping, but I feel like we're kind of clicking together these concepts.
So I never even thought about this, but since I've never been in the southern hemisphere on a boat before, but bearings are always based on the North Pole, not
Correct.
the South Pole, even in
Correct.
the southern hemisphere.
So it's just that your compass rose, you know, your north, everything is from north.
Gotcha. Okay.
Wow.
Yeah,
Yep.
never thought about that before.
Yep.
Yeah, me either.
Cool. Well, I'm glad I could show you that. Like
I bet people in Australia are really upset about that.
well, I did put together a survey, a little Google survey, so I could make the class better. This was my first time teaching it to recreational boaters. So I think it worked out really well, but I'd love some feedback. So I will email that out to everyone because we didn't get too many people in class tonight. But other than that, that's it for the class. And I'm always around. Shoot me an email if you guys have any questions or want to know another class, and maybe we put something together.
So Bree, the email that you sent with the evaluation, that's for the school. And then you're sending out a separate survey for you.
Did you get one from the school?
I didn't get one.
Oh, you didn't? Yeah, I've got an evaluation, an email that looks like it came from you to say, please fill it out.
For Celestial?
Yeah.
I think I got one too, so it might be something that came actually from the school. I
Okay,
haven't-
then if Meta's doing it, it's basically the same thing. I just copied it.
yeah,
And-
I think so, possibly.
But I
If
didn't
Meta's-
get one.
I'll send you one, Robert.
Yeah, I don't know
What if-
where to
send them-
send it to.
Yeah. Bree, just resend them to all of us just to make
Okay.
sure that you're consistent.
It is on the Google Classroom too.
Oh, okay,
So it'll be there.
okay.
Well,
I will
I
scan these
appreciate
and
you
put them up as well.
appreciate you keeping everything up in Google Classroom for a while so I can continue to practice and work on this.
Totally, totally. And even if you pick it up in a couple months and say, how did you get that number? Shoot me an email or call me and I'll give you some reminders.
You're awesome. I've really enjoyed the class. Thank you.
Yeah,
Good,
me
good.
too.
Cool.
It was great.
All right. Well, you guys
So-
have a
All right,
good
well, thank you. This brought back a lot of memories, and
Memory?
it reminds me of how much I don't know anymore.
come back.
So is Google Classroom all up to date now? No more additions?
I haven't put in
Oh, tonight's.
pictures of what I just did for Saturdays or Sundays.
Okay,
So I'll scan those tomorrow when I have sunlight. Better lighting in this room.
right, yeah. Okay.
Oh.
All
All
right,
right.
Hey, it's been fun. Thanks again.
All right. Bye, guys.
thanks
Bye.
very much. It was great.